Okay, so let's start. So I updated more tasks in our templates. So let's see what's added. So first I added integration page on question section. So this contains the general question that we covered or will be covered in our class. So first question is, what is double integral? And today probably we will talk about the triple integral, and you can talk about the multiple integral in general. And second question is, what is an iterated integral? And generally the double integral or multiple integral is not the same as iterated integral, so you have to be careful when you describe these two concepts. And third question is, how do we use iterated integral to compute the multiple integrals? So basically it asks how to use the Fubini theorem and what's the underlying idea of the Fubini theorem. So that's the three questions. And I added integration page. The title is same on the programming part. So far we constructed a struct type MVF, which represent the function, and the task is to implement a integration in this MVF as a method to this MVF struct. And I'm expecting that you can define a method called int, represent integration. And of course, we are talking about the multivariable function. That's what MVF stands for. So you should be able to write the code that works for at least two variable functions. Okay, so we will get to it. I mean, we will do this together. So, but I'm not going to upload my code on anywhere. So you have to follow the procedure carefully, either in class or after watching the lecture video. So, but I recommend you to follow the coding during the class. And the last one, I added the page called Start Writing Your Report in Project. So that's basically lets you to write the report. So let you to start the project on your own. So you can fill out whatever I wrote here, but you can simply read and then start writing your report on your report page. That's basically, so if you go to your page, then let's look at this one. So you have to add your questions and programming and project part, but basically I added in the template that final report should be on this page. So you click this and then you change your title, and then your content of the report should go here. So whatever you have done should be clearly presented in this page. And the page that I mentioned here is that how to start writing that report page. So first step is to write the title. So generally you can change the title as you progress your project. If the result is changed or your goal is changed, then you can change the title, but you have to start with the title because that title gives you the direction or what you want to do during the project. So for example, that's my example, but you can follow that, you can do the same thing. So I'm giving you some freedom to choose, or at least give another option, suggesting that if you have no idea what to do in your project, then you can simply follow my suggestion. And my example is that suppose that I want to do my project on drawing the graph of two variable function. using Go programming language, then my title will be the same thing, drawing the graph of two variable functions using Go. So that title clearly says that my goal is drawing, and it says that I'm drawing the graph of two variable function, very specific one. But I'm not saying that I'm going to draw this specific two variable function. So I'm saying that general two variable functions without D here or specifying the formula. So I'm trying to graph a general way to describe, general way to present the graph of two variable functions in Go programming. So the title, the main point is that your title should give a clear idea what you're doing. So the bad way of writing the title for this task is to say that something like drawing the graph. Okay, so people don't know what to expect by looking at the title, drawing the graph, because you have no idea what to do, what you expect by looking at that title, drawing the graph. What is graph? What kind of graph you're talking to? So the title should be specific. And the second step is writing the introduction. So somehow I try to guide you to write an introduction in previous 2 pages in the project part. But I've seen that, so I've asked the motivation of your research topics and so on, but if you really start writing something, your content should be very concise. People don't care about your backgrounds, right? So people care about their own interest, and you have to point your goal or point your result as quick as possible. So if you need to define some terminology, or if you need to motivate someone about something to make them interested in your topic, then you have to find the fastest way to do that. So first of all, let's say, for example, after my title, I wrote my introduction such as, I'm going to read that. So Go is a programming language developed by Google, because I mentioned the word Go because Go is the word that appeared in the title, and someone would not know what Go is. So I'm trying to give what Go is first. And then in this report, we are going to explain how to draw the graph of general two variable function using Go. So second sentence clearly or specifically guides the reader what is in this content, what is in this report. So title is like concise version of the second sentence. And then I have to explain more, because the question that follows immediately is, what did you do to draw the graph of two variable functions? So, or what is the graph of two variable functions? So I have to explain. If you really explain in detail, then you can define the graph of two variable function in the next section. But in the introduction, you have to at least give reader the idea what is the graph. So I explained that in the third sentence. The graph of a two variable function is a surface in the three-dimensional space in general, right? So that's how we draw the graph of general shape of two variable function. So we will explain the mathematical properties. So so I explained what is graph, and another question is why you care about graphing the two variable function. So I'm explaining why. So we will explain mathematical properties of vectors used in drawing the three-dimensional object to the two-dimensional canvas. So it somehow explains why I'm caring about the graph of graphing the two variable function, because it uses the mathematical concepts, right? So I'm going to explain that. So that's how that's my part of a goal. The goal is drawing, but in the process of drawing, I'm going to explain what is used mathematically. So that's how the reader can benefit by reading this report. And the last one is we will explain how to program such properties in Go. So I'm finishing my introduction by specifically saying that I'm not just vaguely explain how to draw. I'm going to specifically give you the code or explain the code that draws the graph of two-variable function in Go programming. Okay, so you can add more or you can explain more if your direction, your intention of doing this is a little bit different, but that's the concise version. In my point of view, that the most concise version of doing this task. And the third step is lay out the sections. So you should not start, so at least the introduction is something that you can imagine your content of the report should be. And then you have to give a specific picture of what components are required and how these components are interconnected and logically connected. So you should not, once you wrote the introduction, you should start with lay out the sections, not starting with fill in the content of each section. So lay out the section, it means that you give a title and the order of these sections. For example, so I wrote the introduction. You can add more, or introduction could have more sections in it, but I make a one paragraph introduction. And what should be on the next step is that usually if you write a scientific report, then maybe in a high school, they have a format in the report that the first one is like background and second one is how you did it, and then like procedure, and then the result and conclusion and so on. That's how most scientific report follows, but you don't really have to follow that titles because your report is very specific to very specific topics. So you can rearrange your subject and we also change the subtitles of the subsections. So first of all, section, if you're looking at the section 2 to 5, so this 2 to 3 is somehow background, the mathematical backgrounds that required in using graphing the two variable functions. So you have to have something in mind what should be necessary in explaining how you did the graphing the two variable functions. So remember that we explained how we can project three-dimensional graph into two-dimensional canvas by rotating something and then so on. So there were the vectors, concepts of vectors and rotations and so on. So in order to explain that well, you have to introduce what is vectors and how you rotate the vectors and what's the properties like inner product and outer cross product and so on. So that should be explained before you start explaining the code or like drawing the graph in order. But because if you start explaining the graph of the two variable function and then you diverge to defining what is vectors and so on, then the reader might be confused. So, and also if the reader is familiar with all the vectors and these concepts, then they can skip these first two background sections and then move on to the section 4, right? So this is how I lay out the background section about the vectors, and then also I have to explain what is two variable functions because there could be some reader that are not familiar with the multivariable functions, so I have to explain that. So definition could go like what is two variable functions and what is domain of two variable functions and so on. And also I can explain what is the graph of two-variable function in mathematics. So you have to know what it is before you do something about drawing, right? So generally the 3.2 is how to draw the graph of a function, and that could be the and the preliminary that explains the vague idea how to use all of the previous parts to really draw the picture in this two-dimensional canvas, right? So, and then I put this section 4 because in order to explain the code, then you have at least have a basic idea how the Go programming works. So you can add more on the basic Go programming thing, or I'm assuming that people are already familiar with that. So I gave some section about the math package and plotter package that we're going to use in the code. So the last part, the 5, is the result, basically, right? So because that's our goal, the goal is to give a code or explain the code that draws the graph of a function. So that's the result. And these 3 subsections are what we have done. And I actually explained it in the class. So, and then once you lay out your section by title, and then you can fill in the content. That's how you work. That's how you work when you research something. You not randomly search for internet or the papers before you write. You start writing, and then you start search for the references or editing and so on. So you should start writing right now from today, because I'm going to give you the deadline on end of November. So you have to finish everything in November. So I've seen that most students not even started at any of these question sections, answering the question sections. So I'm very worried about those students, because I'm not giving you deadline at all, at least the deadline at the end of the semester, but I've clearly said that in the beginning of the class, beginning of this semester, that if you postpone your work at the end of a semester, your result will not be good as if you started earlier. And you're not going to finish everything. And I already gave you the feedback on your midterm. It's not a midterm, but at least the questions that you answered in the midterm period. And then that's what you have wrote in your hand in a specific time. So if you write it in the Notion, you have more time and more resources, and you have typing tools. So I'm expecting more than what you have wrote in the midterm. So if you think that just answering one sentence would be enough for each of these questions, like this question, not this one, like questions like multivariable functions, and so what is a multivariable functions? If you write it in one sentence, I'm not going to give you any points. Okay? The question is like 40% in your grade. If you miss all 40% of grade, so I'm going to give the absolute scheme of letter grade. So for example, if you have seen this before, it's not it's a portfolio, so let's go back to the syllabus. Yes, here. So 40, 30, 30. So basically if you This is a Go code, by the way. So if you think about this code, then if you got 50 points over 100, then your grade is B minus. Okay. In order to get A plus, you should get at least 90. And so I'm basically, if you do all the tasks conscientiously, then I'm going to give a very good letter. This is how it works. So if you do this, and it's not about doing well. It's if you do all the tasks in time and with very if you put quite at least small amount of efforts, then you cannot miss any of these 3 points. Like you can get easily 40% in in-class activities like question sections, and programming assignment is simply following what I have shown in the classroom. And report assignment is also what you can do easily if you just start working earlier, right? So I'm not asking you to do well. It's just do on your own timeline and then finish it on time. So I'm very worried about people who have not started at all for this time. So I can't do anything about someone who's not doing it. So okay. So don't complain about the grade after if you get a low grade. So I have done anything I can do to give you all possible, all opportunity or all options that you can show you can show your own understanding anything. All right, so that's the next the new task, and I want to give you some inspiring video. I mean, you can watch it later. So how to write something. So you can watch this video if you want to, but I recommend watching it because I really believe that the writing is really important, not only for someone who major in humanities, but also for scientists, because scientists are all about writing. If you want to be a good scientist, you have to be a good writer, because if you're a scientist, you'll be evaluated by paper, written paper, not by how you present well in a TV show or a speech. You're not gonna get that opportunity, that chance if you're not a good scientist, and your scientist is evaluated by paper, and that's about writing. So this guy gives you, it posted some guideline how to write a good essay. So it's on the Korean and also in English. So if you have no idea or not familiar with good writing, then you can consult with this guideline and then give some idea how to start writing. Okay. All right. So any questions? No? 네. Yes, okay. No, you can ask English.
Is there any restricted final format for our project?
Is there any final format?
Final format, yes.
No. So basically, you can write anything on your report page. So for example, let's go here. So here, sorry. So this page is your report. Okay. No, there's no template, basically. But if you start, if you just play around for 5 minutes, at least like 1 minute, you can see that there are many decorative options that you can put in your text. So for example, you can put a heading 1 as a title or subtitle or sections, and heading 2 as a subsections and so on. And also you can change the colors, and you can add the images or embed some pages too. So this is a very nice tool if you write something. So I'm basically, I found that in last year. I didn't know the powerfulness of this page, Notion, but I'm putting everything in Notions these days, including my research. So yes. 네.
제가 노션에 노션을 씌울 때 프로젝트 관련 노션을 씌울 때 영어로 타이핑은 영어로 하되 사진 같은 걸 첨부할 때 그 사진이 제가 프로젝트를 공부하면서 적어둔 필기 같은 건 한국어로 써줄 수 있잖아요. 그 필기 같은 그 필기를 사진 형식으로 올릴 때는 그냥 상관없이 한국어로 적혀있는 그대로 올려도 될까요?
So the question is whether you can upload your references in Korean. So yes, you can upload your image as a reference, even if the image is in Korean. Image contains some Korean language. But I think if you 왜 올리려고, 어떤 걸 올리려고 하시는 거죠?
제가 저희 프로젝트가 일반 상대성 부분에 관련된 거잖아요. 근데 그거를 어떻게 유도가 되었는지를 계략적인 부분을 얼마 전에 좀 공부를 했는데 그거를 올리는 게 유도 과정을 계략적으로 정리해놨는데.
Okay, so if you have a formula, and also you have the process of deriving some formula written by hand, and you want to put that in your report, you have to make it as a formula in the report, not just upload your image. So for example, there's a playground. Let me add more page here. So basically, I showed you a long time ago, but okay, so you can add a formula, like equation gives the inline formula here, like f equals to x, something like this. And also you can put a block equation. So that gives centered formula. Okay, so in a new paragraph, you have to change it to the formula format. Okay. Yeah, you have to type everything. Type everything as you can, because if you're going to upload whatever you have written in hand, what's the difference between handing in your written assignment in a paper and upload your thing in the website? Typing is really important. So you have to type, because at least it should be digitized to publish something, or if you want to keep it somewhere, it has to be digitized. Okay. So I recommend use Notion for your own personal purpose, but once you have done working on a report, you can just simply copy your page to your own Notion page, and then you can keep all of the work, like this, all of this work can be simply copied to your Notion, and then you can keep it as your portfolio. And after a few years, you forgot what is the green theorem is something that appears in the multivariable calculus, then you can simply go back to what you have studied. Because you can remember the best you can remember is what you have wrote by yourself or said by yourself, not by looking at someone else's text. So I'm expecting you. This is your outcome after having this class. Not the outcome of the taking some class in university should not be a letter grade. You have spent tremendous hour in this semester, and then if all you got is like A, B, C, or like this letter grade, what kind of thing that is? I mean, you spend like at least 100 hours of studying this, and then what you get after all is like one letter in a transcript. And it's better not taking any class in universities. Okay, so that's that. And then thank you for asking that question, because many people will concerned about that. All right, so let's start our material. Okay, so let's summarize what we have learned the last time. So the most important thing we discussed last time is that you can compute double integral using iterated integral in some condition that's called the Fubini theorem. So Fubini says that if f is a function, two-variable function defined on rectangular domain, and this rectangular domain has a boundary, so it's a product of two closed interval. Okay, so that's very important point. It has a boundary. Then you can compute the double integral using iterated integral. There are two ways of doing this, but I'm going to write only one for simplicity. Okay, so iterated integral, the order of dx dy matters because of this sign, S sign. And we explain the underlying idea, geometric idea of these equations. So our question is, what if the domain of the two-variable function is not rectangular? So the question is not simple. So what do we mean by what if? So I'm asking whether these equations hold, or what should we do to compute the double integral and the iterated integral and so on. So I have to break this question down to more questions. The first question is, we have defined the double integral for the function defined on rectangular domain. We have not defined the double integral of a function defined on non-rectangular domain. So in order to think about the left-hand side, at least we have to generalize that definition of double integral. So how do we define the double integral of a function? So this D is a domain of a function, but it's a general set. And this D is not rectangular. That's the first question. What other questions can you ask about this question? So what if can contain many other questions. So one of them is how to define the left-hand side. What's the next step? What's the next question? 문제?
이거하기. 네, I mean, can describe it.
Now I'm asking what other questions there could be. Not answer question. Do not answer the question yet. I'm just writing all the questions that you can ask about this question. Okay.
How can we define the domain of f? I mean the integral of f
Uh-huh.
by equation.
By equation. Oh, okay. So that's a good one. So it's a similar idea, but I'm going to elaborate a little bit more. So how can we compute the double integral of the function defined on non-rectangular domain? A similar question, because if you answer one of them, the other can immediately follows. So other questions? So I'm talking about the question that I posed here, because this theorem is about rectangular domain. Okay, so simple question. What if I change the rectangular domain to non-rectangular domain? That question is not a simple question. It's not a yes or no question. Okay, you have to ask more to think about what is this question means. Okay, so what does implied in this what if? So one is that you have to define what is on the left-hand side, right? That's these questions. What do you have to do next? Yeah, so you have to think about what is on the right-hand side, because this right-hand side is about rectangular domains, okay? So the question is how you can define the iterated integral for non-rectangular domain. Okay. Anything else? 철규? Okay, so you want to ask about what happens when you change to non-rectangular domain. You searched for how to think about this number, okay, this concept, how to think about this concept, and next to is what? Are they equal or not? How you can compute, how you can show the equality here. Okay, so it means that how you can prove the Fubini theorem in this non-rectangular situation. How to prove Fubini theorem for non-rectangular domain. Okay. So you have to lay out clear question before you understand something, because all of this idea has been developed by questions. Okay, it's not only for mathematics. If you study anything, you have to have a clear question in mind before you learn something, because otherwise you're simply memorizing what people have done. You're just following by eyes what people have asked and answered. It's not your questions. Learning happens when you ask questions and you find the answer. So I think that's a quite a lot of questions. So is there any other questions you want to ask? No? That's fine. Okay, so let's start with the first question. How can we define double integral on the non-rectangular domain? And also let's combine that with this one. So that is Q1 and Q1 prime. How can you compute that? So I can spend some time by discussing the way you can do that, but let me give an idea of how mathematicians do usually when they define some general concepts. So now let's think about the domain is bounded and closed and bounded. So I'm not going to compute. I'm not going to consider my domain is entire plane. I'm going to give like a small or at least bounded, and the domain which contains the boundary. So closed means that it contains its boundary. Boundary is not same as boundedness. Okay, so boundary is something that you can get. The boundary is a boundary. It's like you have a clear end of each domain, right? So I will give an example of it's not bounded, not having boundary. So bounded means that here every element in D does not go to the infinity. So if you pick one point, like for example origin, and you take any point on the domain D, then the distance from origin to the point inside of D does not grow infinite. So for that means mathematically for any x inside of D. So this x is a two-dimensional point, so it's a vector. I can say it's a vector. So let me give an order here. So there is a large, doesn't have to be large, but at least large is sufficient. So a large number n, which is positive, such that the size of this vector is always less than n for all points in D. So if you think about the point in D as a vector from the origin to that point, then the length of that vector is always bounded above by some number n. Okay? So for example, so I'm thinking about the situation like this. Okay? You have a boundary, and it is bounded because you can put this D into very large radius, a circular region of radius r. Okay? But I'm not thinking about this situation. So for example, you can have xy plane, and then let's say I take this strip, infinite strip to the left right-hand side. This has a boundary. Okay, this has a boundary. It has all clear ends, but it's not bounded. Okay, so it is closed, but not bounded. Okay, so I'm not thinking about this situation. And also, let's say I have a circular region, but the boundary is only at the lower half of the circle. This is bounded because I can put that in larger circle. So it is bounded, but it's not closed because it does not contain the upper boundary. So in order to be closed, it should contain all of its boundary. Okay, so this is bounded, but not closed. So let's work with this situation for now. So we have only, we are talking about closed and bounded domain. Now, how can we define the double integral over this closed and bounded domain? Geometrically, you can generalize the idea. It's the volume under the function, graph of a function over this domain, D, right? Okay. But the question is, as Bonje asked, how can you compute that? Okay. So let's say, let me grab another picture here. So this is x and y and z. So my D is somewhere here. Since this is bounded, I can put that in a larger rectangular domain from x from A to B and y from C to D. Okay? So this rectangular domain properly contains all of its boundary of D. Okay? And then let's define, so over D, so there are graph of function, okay, z equals to f of xy, but outside of D is not defined at all. This function f is only defined the inside or the boundary of D. So outside of D is not defined at all. But we are going to define a new function, which is defined over this rectangular domain, which contains D. So let me write that in words. Take AB cross CD contains D. Okay? And then define another function. It's different from small f, such that the value of f of x, y is equals to small f of x, y, or 0. So if x, y is in D, then I take the value of small f. Otherwise, if x, y is not in D, like outside of D, I take 0. Okay? Then we can define the double integral of small f is equals to double integral of this large f over the rectangular domain. Does it make sense? Yes.
Does it, I mean, the first example remark is close one.
This is closed.
But, I mean,
Closed means it contains all boundary. This is the boundary.
but 그 무한대로 발산할 때 무한대는 처음 하지 않아요?
There's no point in the infinity. Simply there is no one, no point at infinity.
무한대로 발산할 때 그 보통 등으로 표기를 안 하고 부등으로 표기하잖아요.
What kind of inequality are you talking about? Because in going infinity is going infinity. It's not less or equal to something. Infinity is not a number. There's nothing if you go infinitely far away from the origin. You have nothing. You have nothing to nothing to converge. Right? You keep increasing. Right. So if you have somehow there is a boundary of this space, then this doesn't contain the point on the boundary, so it's not closed, but there's nothing here. Okay. So it's a concept appears in the topology. So by the way, next semester we're going to have, I'm teaching the course called Introduction to Geometry, and that course contains some materials in topology that we're going to discuss about these two. So if you're interested, you can take that course, although it's a senior course and not intend to, the level of course is not going to be a senior level. So anyway, yeah, so thank you for good questions. So the concepts about closedness and boundedness is different. Okay? So anyway, we can define, so think about why this makes sense. So first of all, the thing is, f is not defined. You cannot compute the value outside of D. So we enlarge the domain of function, and if you change your domain of function, now it becomes a different function. So that different function is named large f. So I'm defining the double integral of original f as double integral of new functions. Now new function is defined in rectangular domain, and we know how to compute the double integral defined over the rectangular domain using the Riemann sum. So this is well defined. So that value is defined as this value. So how can you compute the right-hand side? So the way we define the double integral is to simply give a subdivisions, right? And then for each subdivision, for example, you take these subdivisions, you take any point inside of this subdivision and take the value of function as a height of the rectangular cube, and you compute the volume rectangular cube, right? So if the subdivision is properly contained in D, then it will give some height according to the graph of a function. If, for example, like this picture, you have a subdivision which partially contains D and partially not contains D, you have options. You have, if you choose your point randomly inside of this subdivision, then there's a chance that your height would be 0 if you take the point outside of D, and you have chance to get a non-zero height if you take the point inside of D. you will have these situations along the all boundary, right? But if you keep increase the number of subdivisions, then this small small subdivisions on this rectangular region is getting smaller and smaller. So the error that you get by choosing the point inside or outside of D, will we get 0, right? The error gets 0. So basically you get everything 0 outside of this D with a small rectangular cube, and then inside of this small rectangular cube inside of D, you will get the volume of the region between these two graphs. And whatever you get along the boundary is somehow, if you keep increasing the number of subdivision, this small error will be vanished. Right? So that makes sense. The easiest way you can compute. So when you want to implement that into your code, then all you need to do is find out A, B, C, D that contains the domain D, and then you have to somehow have a check function that whether your point is inside of D or not. Okay? So if it's inside of D, then you can compute the value of the function using this, and if it's not, then you can just simply replace that value by 0, and if you sum over all range of x and range of y, you get the value. Right? That's the double integral. That's how mathematical usually generalized, but or you can break it into another definition, but I'm just giving you that's how you can generalize. Think about next two questions. How you can generalize the iterated integrals. So think about similar situation as before. Here we have a graph of a function, and this is the domain. And this is y, and this is y, and x. So the idea of iterated integral, you fix one variable and then you change the other variable and then see how the integral looks like, and then you take another integral over other direction. So for example, you first fix your y as y0, and your value of x can range from, let's say, here to here, right? Okay. And then there is a section appears on the graph, right? So when you take the rectangular domain, when you fix y value, the range of x is always from constant to constant. But if your domain is not rectangular, your minimum and maximum of the range of x is changed according to the point y, right? So let me graph that in two-dimensional situation here. So if I take that in two-dimensional, then like this one. So if I choose, so maybe I should make it into something like this. Okay. So if I fix y0 here, then x can range from here to here. If I pick another point of y, then the range of x is also changed, right? So think about the maximum and minimum of y inside of this domain. I can change my y from here to here. Okay? So depending on where I take the slice, the minimum value of x in the range depends on follows this curve. So let's say this curve is G1y. So G1y gives the value of x, which is the minimum of the range, okay? And then if I take the maximum of x, the value of maximum value follows this line. So this is, let's say, G2y, and that gives x max. So x mean and x max are value that depends on y, okay? So let me put that here. So the idea of iterated integral, again, is try to integrate over x first by fixing y, and then change y and then integrate. So let's say our minimum and maximum value of y is here. So y mean is here, and y max is here. So y mean and y max are constants. I'm taking this y mean and y max inside of entire domain D. Okay, so these are constant, but depend on y, x mean and x y are not constant. It's a function over y. So let's say I'm taking integral over x mean to x max at y0. That's x mean y, x max y. And what do I integrate? I'm going to integrate the function f, two-variable function. And what do I change on the integrate from here to here? I'm changing the value x, so dx. This is my integral over this line. And then once I do that, what do I get? I get the area of this slice, okay? So in order to find the volume under the graph, I have to find the volume of sum of volume of stacks of these slices with a small width, okay? So let's say this is AY, okay? So the area of this slice is AY. So I'm going to erase Y0 from now on, okay? And then in order to find the volume is, let's erase definition here, so, okay? So just a remark here. So entire volume is integrate AY from where to where? Y mean to Y max, right? So Y mean, Y max, AY. Okay. So you can write a definition, try to write definition of what iterated integral for non-rectangular domain. Let me give kind of proposition here. So let f be a function defined on two-dimensional space, a two-variable function. So, and domain is a general shape. And let's say D is closed and bounded for now. Then let's say I can describe my D as the following, like that picture. If D is given by a point xy inside of R, satisfying that y is range from A to B. Y is usually C to D, so let's say C to D here. C to D. And for each of y, let's say my x is range from function values, g1 and g2. So g1y is the minimum value of x at y, and g2y is maximum value of x. Then what? So I'm going to take an iterated integral. Yes. First, I take it iterated, g1y to g2y. That's the minimum x and maximum of y, maximum of x of fxy over x. So this part is basically the area of slice. And then it integrate again by y over c to d. This is the volume under the graph over the domain D. Right? Now, there is a very important condition missing in this proposition. What is missing? Is it always true?
What is the letter? What is the word beside the volume?
The volume under the graph of f over d. So if you have a situation like, let's say you can have domain something like this, what do you get? So if I have y here, then x min is here, x max is here. That means I'm trying to integrate over these interval. There are sub-interval not contained in D, and function is not even defined outside of D, so it doesn't make sense. So we don't want to avoid this kind of situation to explain this. Right? That's why I explained D is defined in this way. So there are no point missing inside of D by taking the minimum and maximum of y. Okay? So this means that my volume and my region is a mathematical technical word. It's called not really a convex. I would say convex-like shape because convex is meaning different. So it somehow it doesn't have this concave part of the region. Okay, so it always like round shaped domain. What if you have a domain something like what I've just drawn here, and then you still want to compute the volume over that domain using the iterated integral? If D is a domain, looks like this one, what do you think you have to do? You cannot simply plug in numbers here because, as I said, the minimum of x and y is not contained. If you take simply the minimum x and maximum of x at certain point of y, then there are intervals not contained in D. what do you have to do? Split, right. So split. Split where?
Split the not curve that like this in upper that curve is
Right. Like you split where you can get each of subregion looks like this. But can you think of any systematic way to find out the place where you can split? Right, right. So in order to find the place where you can split, you first find out where you get the slope is 0. Like you have a horizontal tangent line. So for example, let me give a slightly different heights here. So there are 4 points where the tangent lines are horizontal. Okay. So you have 4 options that you can split. You can split here, or you can split here. Let's say you have a horizontal tangent line here, so you can split here, or you can split here. Okay. You can split everywhere if you want to make it complicated, but at least you have to split right here in order to have the left-hand side volume region is something similar to that. So that's D1, and the right-hand side is D2 here. Okay. If you want to implement it in the program, then you have to split everywhere because a program doesn't know the shape of this picture. A human can know that this is enough, but computer doesn't know, so you have to split everywhere, and you have to find where you can find. And then for each subregions, you have to apply the iterated integral. So for example, let's say we have D1 here. Okay. What do you have to do in order to find the volume over the D1? So what's G1 in this case? G1 is this curve, right? And G2 is this curve, right? But now the problem is G1 can be represented by one formula, but G2 does not look like it has a single formula to represent the curve, because this is a curve, but this is a flat line, so you have to split the cases at this point. So you get you have to further split your situation. Say you have this region, and you have this region, right? So first you split D into D1 and D2, and then let me give a different name. So first, the upper part is D11 and lower part is D12. Apply the formula above, or the method above, on D11 and D12 separately. Or there are easy way you can, without separation of D1, by change the role of x and y. So this part is done by first you take the y and first you take the slice at y and then integrate over x, right? But if you change the order, you first take the slice at x and then integrate over y. So basically, you integrate over y first and then x. Here we have integrate over x and then y, right? So, or you can take, so in that case, so what you have to find is you should find where you get the tangent, vertical tangent line. So here and here. Right? And also here, there's a vertical tangent line here. So you can take the x first and then maximum of y and minimum of y. You change the role of x and y and you do the same argument above. You get maximum of y follows this curve, okay? And minimum of y follows this curve, right? Maximum and minimum. So, or you can reverse the order of integration, iterated integration. To compute in one integral. You have to split, but you don't have to even split D1 and D2 in that case, for this case, right? Because if you chop any point at x, then the maximum of y follows these curve, and then minimum of y, these curves. And each curve can be represented by one formula. You can make it into one integration. So sometimes if you change the order of integration, then the computation gets easy. So let me give an example. So you can make any example, actually. So let's say this is 1, 0. This is 0, 2. 0, 0, 2. And here is 3, 2. So you have this kind of, it's not even parallelogram, okay? You have this region, this is our D. And you want to find out, by the way, so you want to find out the double integral here. So let me add one more thing in the proposition here. So then the iterated integral is the volume under the graph over this region. Therefore, what is the volume under the graph? Double integral is the volume under the graph, right? So the double integral of f is same as iterated integral. Right? Okay, yeah. So how do we compute the double integral of, let's say, x plus y over this domain? So one way is you can draw this three-dimensional object. It's consists of flat surfaces. It's a prism-like surface, a prism-like figure, and you can somehow find out the volume using elementary way of finding volumes. But let's use iterated integral. Okay. Let's do xy and yx first, both. Okay. So I want to equate this with two types of iterated integral. First one is taking dx dy and also dy dx. Okay. Let's think about this part. So in order to find this iterated integral to represent the volume, what should you do first in the first place? Find what?
Find the function g1 in terms of y, in terms of
Right. Before you find that function, you first find a range of y. Okay. So y is range from 0 to 2. Okay. So 0, 2. And then for each y, you find out, let's say, where your x run. So basically, this line is minimum of x, and this line is minimum of y. What is this line? This is y equals to 2x. But can you put 2x here? No. Right. You have to be y over 2 because you're taking x values here. Okay. So don't be confused because you're taking a minimum of x value depend on the place of y. So it is natural that you have y here. Okay. You should have y, or at least it should be constant. There should be no x here. And how about the maximum? It's the equation of this line. What is this? Y equals to x minus 1. So what is the equation? Y plus 1. Right. Now, that's it, right? So we don't have to worry about whether your line, this line, stays in D or not, because it always stays in D. Okay? So this will give a proper volume of the graph of function, x plus y. Now the next question is, you want to reverse the order of iterated integral. Can you do this? Okay, so because if you think naively, I'm changing the role of x and y. Let's change the limits here. So you put the limits of y here, and you put the limits of x here, because I'm taking y first and then x. Can you do that? Yeah, you actually have to laugh when I do this, okay? It's nonsense. Why it's nonsense?
because well, actually this is because y plus 1 and y over 2 is not the range of x.
It was range of x in this integral.
The range of x is constant because we said we defined closed and boundary domain. So this really makes sense.
Right, well, if you simply follow the same way we did in the previous part, and we know that this X should run from entire domain, you have to find the minimum and maximum of the X inside of entire D. And that's the right way of doing this. But once, so clearly if you want to say one thing that doing this is wrong, what would you do? What would you say? So I've seen many answers in the midterm in the previous years that students are doing this. That's after I explained everything in many ways that how to compute the volume by changing the X and Y. But people don't understand. It seems that it's not hard, but I simply don't know why they don't. I don't know, but it's not like they don't understand. It's like they don't want to understand. Okay. What do we get after doing this? You get numbers, right? What's the meaning you have y's in the limits? Right, so basically your answer will be in terms of y. So you're not going to get a number, right? So it doesn't make sense at all. I mean, you have to get a number, right? So if you think one more time, then you can say this is nonsense. So what you have to do is change the role of x and y. The role doesn't mean that you're changing the places of x and y, okay? So saying the role of x and y is that first you take the minimum x and minimum y inside of this domain. What's minimum and maximum? 0 and 3. Now the question is, what's the range of y at some point x? Like x can be here or here, or anywhere.
I think the point 0, point 2 is the 1.2.
1.2, yes. So you have to find out the formula for these function. The function whose graph is like this, and function whose graph is like this, right? But you cannot use one formula to graph that function, right? So what you have to do is split, right? Split where? Right, you split case when x is less than 1 and bigger than 1. Right? Then the maximum value, minimum value has one formula, and maximum, minimum has one formula. So it tells you two things. You cannot change the order of x and y and assume that the number of integration stays at 1. You might need more integrals by changing x and y, and also you have to find your new new minimum function and maximum function. So let's take the first case. When x is from 0 to 1, what's the minimum of y? So what goes here? It's a function of x, but it's 0. Okay, so 0 is also a function of x. It's a constant function that doesn't appear as x. And how about this? 2x, yes. Now you can get x formula here because we're taking over y. And then what happens when you take 1 to 3? What's the minimum of y? Yeah, x minus 1 here. And then what's the maximum? 2. So if you compute these two, let's compute one. Let's compute the first one, because so when you compute the iterated integral, you remember that you take the other variable constant. So you're taking over taking x as a variable. So you take integration over x. So it's 1 over 2x squared plus yx, and you plug in x as y over 2 and y plus 1. And then you plug in these numbers, 1 over 2, y plus 1 square, y over 2 square, parenthesis, and y plus 1 minus y over 2 dy. And you simplify this. Then this 1 over 2, this is 3 over 4 y squared, 2y plus 1, and 1 over 2 y squared plus y dy. And then multiply, integrate again. It's all about y, so you get number. And you can check that this is equal to sum of these two iterated integral. Right? So please do not just change the numbers here, okay? Okay, let's summarize what we have discussed here. So it's also called Fubini theorem. It tells that if you have a non-rectangular domain, such as D equals to x is from A to B, and for each x, y is always from H1, x from H to x, then the double integral of dx dy is equals to h1x to h2x f dy dx. And if you take D as y is from C to D and x is from G1y to G2y, then the double integral over D is equals to CD G1y, G2y, f dx, x dy. So that's the Fubini theorem in non-rectangular domain. That answers our 4 questions that we discussed in the beginning. Let's generalize furthermore. So far we have discussed the double integral. You probably heard about triple integral. What do you think the triple integral is? Jian, what is triple integral? What do you guess? Right, you need 3. What kind of 3? So double integral is about how many variable functions? 2. And triple integral should be about 3 variable functions, right? So let's define a triple integral over rectangular cube first. So it's the same procedure we discussed about double integral. You have a rectangular cube, and you have three variable functions. Now, I'm going to just define the same way we define the integrability. So this is how it's defined. You take the number of subdivisions, and then let it go to infinity, and you sum it over ijk from 1 to 0 to n minus 1. So although I put the 1 sigma there, you should think of this as has a 3 sigma. Each of sigma contains I, j, k independently run from 0 to n minus 1. And then you take xi star, yj star, and zk star times delta xi, delta yj, and delta zk. This is the triple integral. So what do you think this means? 재현이 옆에 이름이 뭐죠? 윤성? 처음 왔죠?
아니, 두 번째.
두 번째예요? What do you think, 윤성?
Three-dimensional domain.
Three-dimensional domain is it a number or set? Set. But what do you get after taking the limit? What do you sum over here? The value of function is the number. What is this? This is the length of subintervals. What do you get after you multiply all these 4 numbers? It's a number, right? And what do you get after sum over the number? It's a number. And what do you get after take the limit? What do you get? A number or set? What do you get after you take the limit? Is it a number or set? Okay, so it's not a hard question at all. So what is this value? What is this? F of xi star, yj star, jk star? Number. It's a value of function. Okay. What is delta x, delta y, delta z? A number or set? Number. Because I'm multiplying. I cannot multiply the set. It's a number. What am I doing here? I take a sum of numbers. What do I get? Take the limit. Number. So this is number. So what does number represent? What did the number represent for the double integral? In the double integral, what did the number represent? What was the double integral? What does it mean? What does double integral mean? So we have discussed so far about the double integral. If you cannot understand, if you cannot answer what it means, it doesn't. What's the point of? So that my whole goal is not to. So if you can't calculate these kind of things and don't know what the meaning, it doesn't, that's pointless. So we have discussed the double integral. What does it mean? What does the double integral, this is a number, okay, double integral is a number. What does that number represent? Forget about triple integral, double integral. What does double integral, the value of double integral represent? Other people? Volume. Volume of what? Under the graph, right? So then the triple integral would represent what?
Is it okay to say like really personal view?
Yes?
If we eliminate the f in that sum,
Uh-huh.
then we just get the volume on the three-dimensional space.
More specifically, volume of what kind of three-dimensional space?
The cube that,
Cube, yeah.
but we have a function f, and because I actually saw that kind of equation in physics earlier, so I thought f gives some mass or
Mm-hmm.
or some probability, like
Mm-hmm.
some physical quantities
Mm-hmm.
that distributed on the over the three-dimensional
Mm-hmm.
spaces.
Mm-hmm.
So I thought maybe that is, it's not just simply a volume, or it is not just simply a probability, but
Mhm.
it tells us the distribution of f
Mm-hmm.
over the three-dimensional space.
Right. So if you think this is a probability, then and this domain is entire domain of this set is entire domain of f, then you take the triple integral, you get 1, right? That's a probability. But okay, so that's a good point of view. So so what he said is that if this is 1, so then we simply get the volume of this rectangular cube. But since this is not 1, you can replace this by density, not a mass actually, the density or probability, then our distribution, then you get some other meaning of this triple integral. Mathematically, we don't care about whether this is a density or distribution, so we just call it a volume. Volume of what? So here in double integral, we get the volume of three-dimensional region. So this is a volume of what dimensional? Four-dimensional. Why four-dimensional? Well, you increase the number, but if you think about the graph of three-variable function, graph of three-dimensional function, we discussed it in the beginning of this semester. That's the four-dimensional object. A four-dimensional, it's a three-dimensional object lies inside a four-dimensional space. So we basically think about the four-dimensional region bounded by the graph of three-variable function and the three-dimensional cube. So that's a four-dimensional thing. We cannot draw, or you cannot imagine, but it is somehow the same idea of what we have discussed in the three-dimensional space. Let me write that as a remark. The triple integral, let's say v here, so dx dy dz is the volume. So I'm taking volume here. It's a quote volume because if the value of function is negative, then it's a negative volume. Volume of volume under the graph of here w equals to xyz over the three-dimensional domain V. But that doesn't give a clear idea. So let's give some special situation. If fxy is a point density so usually density has a unit like kilogram over meters cube or something like that, but so I'm using the same unit, but somehow let's say we can measure the density at that point, a small point, then we can represent it as a function fxyz, then the triple integral is what? What do you guess? So if the integrand represents the density at each point, then the total triple integral would represent mass, total mass of V. Okay. Why? So we have divided our domain into smaller rectangular cube, and then the volume of that smaller rectangular cube is this. Okay? And then we multiply by point density. Although we take the point density at a random point inside of this subregion, if you make it smaller and smaller, then it's almost equal to the density, almost equal to the small mass of this small rectangular cube, and we sum over the entire index, and then we take the number of subdivision goes infinite, so it's basically the same. It gets same to the total mass of this volume. Or you can give another meaning if you have a different situation that explains the function f. But basically the same idea, and you can generalize to fourth integral and fifth integral and so on. So basically in differential geometry you can define the integration over like n-dimensional space. And the Fubini theorem stays the same way we describe in the double integral. So we have, let's say, three-dimensional object, which is not a rectangular cube. If it's a rectangular cube, it's defined, well defined by this limit, the same way we did in the double integral. But if you have a non-rectangular domain, I want to say that Fubini theorem holds the same. So we do the whole question again with the triple integral. First, how can we define the triple integral on non-rectangular domain? How can we define the iterated integral? And why does triple integral same as the iterated integral over three variable function? So first of all, how can you define the triple integral over non-rectangular domain? Jian? Say it loud. I cannot hear anything.
이게 접근할 때처럼 이제 마찬가지로 범위를 나눠가지고 하는 거 아닌가요?
No, I'm talking about the triple integral, not the iterated integral. How can you define the triple integral? How did we define the double integral? Before we do the classical Riemann sum, that only applies to the rectangular domain. We have non-rectangular domain. What do we do? What did we do? So let's say V is closed and bounded. Yeah, you can check the range of x and y and z axis. For what? I'm talking about the triple integral, not triply iterated integral. Triple integral itself should be defined to say that the Fubini theorem is true. Triple integral on the left-hand side is same as triply iterated integral on the right-hand side. So we had a double integral case. In order to generalize the double integral on non-rectangular domain, what did we do in the first place? That's like 30 minutes ago.
Divide a function that is, if the x value is out of the domain, then we assign the value 0.
Right.
And, yeah.
So where does that function defined? What's the domain of that function? What's the domain of that new function? So I keep saying that I want to define the triple integral over non-rectangular domain. Over the rectangular domain, it is defined. How do you define the non-rectangular domain here?
Well, simply find the cube that contains that.
Right. You find the cube, larger cube, because it's closed and bounded, right? So you can always find the cube that contains V. Right. Right? So this cube has x range and y range, z range. Now it's a rectangular cube. It's well defined by Riemann sum. So you can define the, so here this cube is C, okay, of this large F. You can define that as a triple integral of your function defined on the non-rectangular domain, right? So and then we're talking about, we need to talk about triply iterated integral and how the Fubini theorem can generalize to three-variable function case. So think about this function, and let's say if I project down onto the xy space, then I have this domain. Okay. What I try to do, I want to find whatever inside of this domain, when inside of this three-dimensional space. I pick a point. Okay, I pick a point inside the projected space, inside of this region D. That's my x and y, and I pick maximum of z and what? Maximum of z and minimum of z. Okay, z max and z min. Okay, these two values are not a constant. If I change my x and y, it changes. But what do I get when I take the integral over z min to z max of the function? What do I get here? For example, if I have f as the point density, what do I get? Taking integral over z. You get a density over planar surface, right? Just think about the unit. You have a kilogram over meter cube, and you integrate over dz, which is a unit of meter. What do you get as a unit? It's a kilogram per meter square, right? So that means if you take the xy in a small region, then and then you take the rectangular over that small region, you get a small mass of this small thing, right? So basically you get a mass of this line, right? If you take the line as some measurable thing, then you get a mass of this line, right? So, and then what do you have to do? Find out the entire volume. So you have a mass of line over over one point, x and y. You add that mass over x range, okay? Or you can take it as a y range. I take the x range here. So here I have a slice over like this, okay? If I range my x from minimum and maximum value, I get a slice. And if I integrate over that slice, I get a mass of that slice, right? And that's x mean to x max. So x mean and x max is dependent to y. It depends on where I cut this point, right? So it's a function of y. And then next, in order to find entire mass, what should I do? I add all these thin masses, right, over y, right? So I take the y mean and y max. So is y mean and y max constant? Yes, it is constant. So I'm taking the minimum value of y inside entire volume V, and then that's the volume. That should be the volume, which is the triple integral. That's the Fubini theorem. So let me restate the theorem because we don't have much time. So in a Fubini theorem in triple integral situation, we have V as, so if I take that situation, y is from C to D, and according to that y, x range from G, what was it? G? Yes. G1y to G2y. And then according to that, x and y, z runs from f1xy to f2xy. That's the situation. So we have a two-variable function that represents the z max and z mean. That's the function f1 and f2. Then the triple integral is equals to CD G1y, G2y, and F1xy, F2xy. Oh, sorry. Well, let's say the same thing F here. So this is different from F. Okay. X, Y, Z, dx, dy, dz. Okay. That's the Fubini theorem in third version. So this contains the case when the domain is rectangular. Okay. So if V is rectangular, these all functions are constant functions. But it works with a general shape. So you can start thinking about the same question, exactly the same question we discussed in the double integral. What if we cannot find a single formula to represent the z max or z mean? Then you have to split your volume into two pieces that you can use one formula for each limit. Okay? So how you split the volume is also you have to find out where your tangential planes are in horizontal directions or vertical direction and so on. Right? But if you have an intuition, Like if you can draw your volume and if you use your intuition, you can easily find that. So we're going to give some examples of triple integrals and iterated integrals in next time. Okay, so yes, question? No? Yes.
So like there is a mixing of dy and dx on the.
Oh, sorry. I made a mistake here. Which one is missing?
Also there is air and in the left below. Like,
Here?
I mean, left wall.
Here?
On the left.
Here. dy, dx, dy. Right. Thank you. All right. Let's call it here and then see you on next Tuesday.